Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve question number 53 from GATE 2015 exam. In this question, it was asked a monochromatic plane wave of wavelength 600 nanometer is given by this expression, and this plane wave incident normally on a diffraction grating, giving rise to another plane wave in the first order of diffraction. So if this is our diffraction grating, tan a incident plane wave, which is E0 e to the power I k z minus omega t, it diffracted into the expressions of E1 e to the power I k1 dot r minus omega t. Now the period of diffraction grating is. We have to calculate what is the period of diffraction grating. We are given the k1 vector, and now the k vector is given by gradient of kz, which is equals to k cap direction. Kz, which is equals to k cap or z cap direction. So this is our k1 vector and this is our k vector, which is mod of k into z cap. Now we know that the sine theta angle is given by the cross product of k cap cross k vector. It's a simple way to calculate the sine of theta between two vectors. And when we put the value of k vector and k1 vector, their magnitude will get cancelled out, and we are left with z cap multiplied by 1 by 2 x cap 3 by 2 square root of 3 by 2 z cap. Z cap with z cap will give you 0 and z cap with x cap will give you y cap. So we are only left with an expression of 1 by 2 in the y cap. From there, we will get the value of theta, which is 30 degree. So the grating equations, which is give t sine theta equals to n lambda, and we, so n is equals to 1, we will get the value of t due to first order. So the value of t equals to lambda by sine theta. Lambda is given as 600 nanometer and sine theta is given by sine 30 degree. So it will give 1200 nanometer. But the question is asked in micron meters. So the period of grating is 1.2 micrometer. So the correct answer is 1.2 micrometer.